All right, yes. Thank you, Fab, for that fabulous introduction. My name is Brian Hoover, as you already said, LabVIEW Architect. I currently work for Samsung SDI in Michigan. Um, and if you recognize the little Homer Simpson head in the forums, that's me. Yeah. So some of the stuff that we're going to be talking about here in XNodes, there's a lot of great stuff. But before we jump right into it, the first thing that we have to cover is the little disclaimer that I'm sure many NI employees that are watching are probably hoping I would say something about. XNodes are not a technology that NI wants you to use. Well, they are unsupported outside of NI technically. They don't have as much documentation. There's not a whole lot known about them. That being said, they're not unstable, so to speak. They're not something that you can't use. They're on the palette today in several forums that I'm going to be showing you about, and there's a lot of really cool stuff that you can do with them. So there certainly is some drawbacks, and documentation and uncertainty with them is one of them. But the benefits of them is you get to do things that you didn't think were possible, that I didn't think were possible within the LabVIEW IDE. And that's something that really excites me. That's really something that I like to see. When I see something that I was like, oh, I thought only NI could do stuff like that. That excites me. I want to be able to have the same tools or similar tools to what NI does, and XNodes is sort of a gateway into being able to do some of those things. So now, finally, let's jump right into it. XNodes, right? But not just yet. There's a couple of things that. I moved my slides around. I'm terrible at this. I should have known that this was coming. I presented this at a user group recently, and the problem was I didn't talk about XNodes right away, so I used the word XNodes so many times that people didn't know what they were. So I moved this up in the presentation. Sorry about that. I wanted to give a definition of what an XNode is first. An XNode is a node on the block diagram that performs an action as it's interacted with through ability VIs. It's sort of what you get when you combine an XControl with LabVIEW scripting. It allows for event-driven edit time execution of VIs. This is, again, only for the block diagram, not on the front panel like an XControl like you maybe are more used to. They're incomplete, they're poorly documented or not documented at all, depending on how you look at it. But the technology is stable, and at the root of it, an XNode is just a LabVIEW library. It's plain XML with a bunch of extras thrown in. But the file itself is just plain text that we can look at that has ability VIs. So it's going to be hard to show examples of XNodes. So I wanted to start with examples of XControls and LabVIEW scripting. At the user group that I presented this at, they weren't nearly as advanced users. They weren't on the deep end of the pool. So I had to cover these topics a little more than I thought would be necessary. But hopefully you somewhat advanced users are at least passingly familiar with LabVIEW scripting and XControls. Really the best way to understand XNodes is to first at least touch on these two topics. Now, these topics alone.
Just Brian, just let me ask here. So you said many people are here familiar with scripting. Okay, the whole room raised their hand. And then what was the other question? What was the other one?
XControls.
XControls. How many are familiar with XControls? Yeah, we had a couple of shaky hands, but most of them raised their hand.
Okay. Well, if you're familiar with these topics at all, you know that you could probably have like a couple of day hands-on training on either of these topics. And, you know, I don't want to spend a couple of days on these subtopics. So instead, I'm just going to show a couple of quick examples. And then hopefully these examples, you'll remember them when we talk about XNodes, and you'll make the connections. You'll see how they relate. So the first thing I'm going to do real quickly is show a scripting example. It sounds like everyone is at least familiar with scripting at some level. But it's basically LabVIEW code that writes LabVIEW code or edits existing LabVIEW code. In other languages, it's a pretty common thing to be able to write a text file that is code. But in LabVIEW, that was a little bit more of a challenge. So we really couldn't do that until 8.6 officially when it first came out. So I'm going to open this scripting example. And again, all the examples I show are going to be available after the presentation. Or actually, they probably already are available if you looked around on the user group. So here is a basic scripting VI. I don't know if you guys are presenting this on a projector, so I'm sorry if this is, too small, but I can walk through the bits and pieces. Basically, we create a new VI, we wait a little bit so that we can see the process. We get a reference to the block diagram, we add an add function, we get the terminals on the add function. Then if it's a input, we create a constant, and if it's a output, we create an indicator. And we do that for all of them, and then at the end, we do a little cleanup. So I'm going to run this, and I don't know how well this will translate to shared video, but on my end, it's it'll take a second between each operation. So here's we add the add, we add an indicator, we add a control or a constant, and then another constant, and then cleanup. So I didn't touch anything to have that happen. It did it for me. And scripting can do so many more things than just create an add function, right? That seems a little, that's not a very useful thing to do. But if you want to do a set steps on a whole bunch of VIs, you can say, do that. For my folder of VIs, go do stuff. And with this, it's a lot of powerful things you can do. The quick drop, right-click framework, the project, crap, I forget what it's called, the project creation wizard that started in LabVIEW 2012.
Project templates.
Project templates, that's it, thank you. There's a whole lot of scripting that can go on in there. There's a lot of cool things that scripting can do to automate a task or to edit some existing code. And I know that there's just a lot of cool stuff. I don't really need to talk about it if you guys already know a lot. But making VIs, editing existing VIs, this is some very cool tools for doing that type of thing. And XNodes leverages a lot of this in the background. The next example that I wanted to talk about was the XControl. So in doing that, I'm going to demonstrate one of my favorite XControls, this variant tree XControl that is on Lava that you can go download in our code repository. But basically, an XControl is a front panel object that is a collection of VIs in an XML library. VIs are they are a member of that library, of that XControl, and some of them are ability VIs that can have certain attributes that get ran at various times as you interact with it. It's a little hard to describe, so I'm just going to demonstrate it a little bit real quick. So we are going to go to the XControl example. And so here I'm running a VI, and I have a little toggle switch down here on the bottom. Up top, I have system data, that's a cluster, and down here I have test results, which is an array of a cluster. If I toggle the switch, we see that this variant tree, which is actually an XControl, is updated with the data from this array. You can collapse it and see that the very top level is test results. You open it up, and we have test name and status, and inside that is a status, or is test name that is a string, and test status, which is a enum, and it shows that its test failed. And it basically shows the value of this array, but if I toggle it back, now it shows the value of that cluster. It's a very cool thing for debug. If you have a messaging library and you're just sending variant data from one place to another, this is a great way to see what is the values and what is the structure of the data that's being passed around without it having to know the strict type of everything that's been going on, because it's a messaging library. So if we look at the code to this, it's surprisingly simple. We basically have the cluster and we have the array get turned into variants, and then we have a toggle that says which one do we pick. This extra code up here is not really useful. It's just it's causing it to not update the tree unless the value changed, because then it updates all the time, and then you can't scroll because it resets the tree. That's not really important for the demo. Really, it's just this little bit. We have variants turning into, or clusters and arrays turning into variants that get displayed. Now, how does this work? Because on the front panel, this just looks like a regular tree control. I mean, it's a tree control with some coloring applied, but it's just a tree control. Well, it works because it's actually an XNode. I'm sorry, XControl. I'm jumping ahead. Here's the actual XControl that we are calling, and we open it up in LabVIEW's IDE, and we see that it is a library with a whole bunch of things in it. We have folders for methods, so these are like invoke nodes. We have a folder for properties, which are property node equivalents. We have other stuff that's not, it's just utilities. It's helper VIs. And then on the root, we have the state data, a facade, or that's an ability, sorry, the facade, and another ability that is the init. So this collection is the XControl. So when we have it on the front panel, you drag the XControl onto the front panel, and bam. Now you notice when I drop it down, I get this little dialog saying, hey, configure me. And this happens because a VI is ran when a new instance of that XControl is made. I'm just going to click OK and be happy with its settings. But how does that happen? It's because on this XControl, we have this init ability. We can open it up, and it's a VI that has a lot of things for configuration management. If the version is revved, how do we handle that? And the developer, for some reason, wanted the icon view when you first dropped it down. But in here is the actual dialog that we see for configuring it. And this is, again, ran on first init. How does LabVIEW know to run this VI when we make a new instance of it? Well, it's because this XControl has that ability. When you right-click on the XControl, you can say create a new, and we're familiar with properties and methods because those are property nodes and invoke nodes. Those are just VIs. But here we have abilities. And in this ability, if we add this ability, it'll tell you like when this is ran. So you can see we have data, state, facade, and init. If you read the description of init, it'll basically tell you that the init ability is going to be ran when you first create an XControl. If you read the uninit, it's pretty self-explanatory. If you created this ability, it'll get ran when you deinitialize, or when you basically delete the XControl from your front panel. And you could do things like clean up references or close things that maybe deal with your XControl. Yes. And the facade is kind of an interesting one because it's got an event structure with all kinds of various things that can happen, like if you turn the control into an indicator, or if you write data to its terminal or a local variable, what should we do and how should we behave? All of that is defined by this collection of code that is turned into a single XControl. It's a single XControl containing all of these things. Well, what's interesting is if we open this XControl in a text editor, we see that it's just plain text. It's XML. There's up at the top talking about the icon and how that should look, like especially on the palette. It's got a name, it's got version, it's got a bunch of flags. Here is the folder structure. We have folders with property folders. If we keep going, we have a folder with the utility code that I mentioned. And then down at the bottom, we have these ability VIs. So here is the ability VI, and this one is a data ability, and this is a state ability, this is a facade, and this is that init ability that we talked about before that is ran when we first create it. So the takeaway from here is, again, XControls are just a library, just like many other libraries in LabVIEW. It's XML text. You can open it up, you can edit it, you can, assuming it's not password protected, and it's a collection of VIs. Particularly the ones that pay attention to are these ability VIs that are special and get ran under certain conditions. Okay, so back to the presentation. Now that we covered scripting, which is code that writes code, and that we've talked about XControls, which is a collection of VIs in a library that behave a certain way, we're finally ready to talk about XNodes a little bit. So if you want to do some XNode editing, the best editor that there is arguably the one that's built into LabVIEW, but it's private. It requires a license that NI is not giving out yet, and it's not a license that you can buy. It's not like a application builder. But similar to Application Builder, it disables features until you have this license activated. So, like if you didn't have Application Builder and you're in the project and you right-click and to say create a new exe, it'll warn you and say you don't have a license to do this, or I don't actually know how far it'll go. Maybe it'll let you make it but not build it, because I've always had Application Builder installed. But XNodes are the same way. You're not going to have all the functions of the LabVIEW IDE because that's not enabled. But to help with this, there is a handful of LabVIEW INI keys that you can turn on. The first one there, the super secret scripting special stuff, is for enabling private methods. So that one's not required, but you might find some of the utilities useful in making XNodes. And the rest of the stuff, we're not 100% sure, but some of it definitely adds right-click menus on XNodes when they're on the block diagram. So with that in place, how do we make new XControls, or XNodes, I'm sorry, and how do we edit XNodes? There was an XNode manager made around LabVIEW 8.2, 8.5 era, and it wasn't bad. It was a good starting point, but it was kind of limited because it required being updated for each version of LabVIEW. So I made this XNode editor. It allows you to create new XNodes, open existing XNodes, add abilities to each to XNodes, edit the description, edit the icon, various small things like that. And the source to this is all posted on Lava. So let's, I guess I want to demonstrate a few XNodes on the block diagram first, and then I'll go back and make some. So the first couple of XNodes here that I want to mention are ones that are already on the palette today. They are well, I'm going to pick the error ring. That's one of my favorites. So if I close out some of these, on the block diagram, right click, dialog and user interface, error ring. So here is an error ring. It's just an error. It's just an error constant at this point, right? If I create an indicator, it's an error, and if I run it, it's no error. But if I click on it, this little dialog comes up and asks me to configure it. Now this is similar to an XControl, remember, where we had to configure on the first creation of the XControl, where it asked us what we wanted to do. This XNode waits a little bit until you click on it to configure it. It gets configured with default settings, which are no error. Well, here we can pick an error that we want to be. So how about under the LabVIEW codes, we probably are familiar with a lot of these low ones. How about operator canceled, 43. One of my favorites. So here's error.
I don't like that one.
So here's error 43, and if we run the VI, what do you know? We get error 43, and it's got a status code of true, and here's some description, which is the call chain to get to this VI. We can do other things like clicking here will turn it into a warning instead of an error. Maybe that's what we want it to be. Or we can click here and turn on and off the call chain. So now it will or won't include the whole chain of VIs that bring us here. This is pretty neat. We can interact with it by clicking. We can click on the arrows. Oh, another fun thing, you can actually add custom errors at the bottom. So I can say custom error code 43. Not sure why you closed or canceled, but it was running process %s. So now we have this input, and we can say, you know, this could be a control, or this could be some other thing, process init. So now when we run this VI and we explain the error, it says what I typed in there. It's still error 43, but we have some extra information. Not sure why you canceled, but it was running process init. It's a pretty handy little function. So some of the features of it is clicking to have a dialog. We can add terminals by adding things like %s and %d, and it's not doing anything we couldn't do before, right? We could have a error constant, turn it on, error 43, and we could add the whole call chain, and we could add this, and it would be the same thing. But it's super convenient to have it in this form. This is actually an XNode, if you didn't catch on already. And by having those INI keys I showed earlier, when you right-click, you have the XNode wizard menu. So here, why don't we look at the generated code? Now, this is going to be the code that is ran when this XNode gets ran. And I'm going to clean up the block diagram because scripting code generally is ugly. But here is what it would run. We have a format into string. We have an input, which is parameter 0, going into this, which is creating the error code with the call chain, and then out comes our error. Pretty simple. I can change this, and oh yeah, let me just, how about not include the call chain. Now I can right-click and look at the new generated code, and we'll see that we don't have including the whole call chain here. How this is working is because as you interact with it on the block diagram, this VI is made at edit time. So as you click it here, as you click it on the block diagram, the VI is being generated. As you click this arrow and you change the error code, or you add, let me add a %D. I have to do it twice. Now there's 2 inputs, and it recreated this format into string, but it's got 2, and it's added the I32 input as well as the string input for %S and %D. So this is a pretty handy little piece of code, but behind the scenes, it's very simple. It's not stuff that you couldn't do on your own. It's just doing that for you, again, by using scripting. Because they're built into LabVIEW, they're kind of locked down a bit. So some of these other items, like what does it do on click, what does it do on initialize, are password protected and locked down. So as far as demonstrating this XNode, that's about all I can show. But why don't we get into some open source XNodes and really have some fun. So here's the next XNode I want to demonstrate that's not done by me. This is on the NI forums. It is a truth table. You give it 2 Boolean inputs or 2 Boolean array inputs, and you get an output that is equal to the data type of your inputs. And it's got a nice little picture showing you how this truth table will be evaluated. So here is my XNode, and just like an XControl, it's that single file that I drag onto the block diagram. And now here we have our truth table. I'm going to create a constant. I'm sorry, is there a question?
Wait a second, stand by. The projector thought that we were idle. A technology too smart.
Projector turned off and the screen went down.
I'm thinking that's what it is.
The projector turned off?
Yeah, projector turned off. Screen disappeared.
Power saving.
Yeah.
Yeah. Probably somebody in the next room did something. Maybe.
Display 1. What did you do when
you know what? I plugged it in.
they had display 1?
Yeah.
Use display to turn on projector and drop screen. So let me do typical software engineer response. Yeah, let's restart and walk in again. So turning it up. Alright? Yeah, we had this problem before. And then go and let it. And then do it again.
Yep.
Sorry, Brian, almost there.
It's all right.
It's like I'm in the middle of the movie. I want to see what happens next.
Well, I'm glad you're on the edge of your seat because, this stuff is, like I said, where we're getting into where it's open, so I can at least walk into some of the code and how it works.
Okay, so I'm not gonna.
Okay, the projector's coming back.
Oh, cool. It woke up. All right, so now it's just giving us this lovely marketing image.
Hey, if you guys want, I can speak for a second about the licensing of XNodes.
Yes.
I was just talking about. No, I'm just going to sit right here, Alan, because I'm comfortable. Anyway.
Can you hear Brian? Can you hear him?
It's a little quiet, he's a little quiet, but I can hear him.
Fine. long. We decided that it would actually be pretty cool if we released the XNode license to people that want it, because there's really no business reason for us to keep it hidden. It would be a really small group of people that would be able to utilize it and utilize it effectively like Brian's been doing. We actually had approval across the board for marketing and R&D management to release the XNode license to the public. And unfortunately, we ran into some technical issues with the way National Instruments licensing works, such that we couldn't actually get this internal license distributed externally from NI. Like, just the licensing infrastructure just wouldn't support it, and it was a showstopper, and nobody had the resources or bandwidth to fix that issue. So it's not a policy reason that we don't distribute the XNode license. It's a technical limitation that we have not currently overcome.
So Brian, I guess if you want to pocket some money, they will they will go over.
Well, Darren, you are aware of the workaround, right?
This is your presentation where you're giving away all the INI tokens. This is not my presentation. So I'm not thinking of any workarounds at this time.
Okay, I did not speak of anything then. All right, is the projector back on yet?
Yes, you're up. Sorry.
Okay, all right. So, sorry for the little intermission. So here is a truth table XNode, a fun little XNode that has 2 Boolean inputs and a Boolean output. If I have a false and a false, we can see here that the output should be true. When I run the VI, sure enough it is. But the fun part of this is you can click on it and change what the truth table should be, and by just clicking. So now I run and it should be false. This XNode is obviously not a 32 by 32 pixels. It's not limited by the constraints of a sub-VI. And we can do some interesting things like adding inputs that aren't scalars, but instead are arrays. Now you can see that the output then changes based on my input being changed. This sort of looks like polymorphic VIs, because you can say, oh, well, there's a limited number of data types that this function should support. It's only scalar inputs and array inputs. But it's not polymorphism. It's scripting on the fly, creating the code that goes along with either accepting an array or accepting scalar values. So just like before, we can right-click, go to the XNode wizard, and show the generated code. And I'm going to clean up the block diagram a bit. And if you look at it, it's relatively simple. You can see here's the truth table that we added. Here's our input as arrays. We turn them into 0s and 1s, and then we index and outcomes our arrays. Pretty simple code, but the convenience and the documentation, the self-documenting more or less, of this function is where it's at. That's the main benefit of this. It's not that it's doing code you couldn't do. It's just doing the same code in a little more self-contained and easier to use way, similar to what an XControl can do. So because this is unlocked, we can also look at some of the ability VIs. So things like what's it do when you click? So here's the operate click, and I'll get into how to create an XNode and how to create those with my editor. So here's the VI that gets ran when you click it, basically. Just like the init VI that is ran on the XControl when you drop it on the front panel, this VI is ran when you click it. Now, what's it do? It reads the point at which you click. It brings in some state information. It recreates the truth table based on what you clicked. You're XORing the previous value with the cell that you clicked. And then we go and redraw the inputs, and we go and generate the code. We have to redraw the image, not the inputs. We have to redraw the image because we clicked it and a true turned to a false, or a false turned into a true. We can also look into the image generating code and see we give it the truth table in, and what comes out is this image. And in here you could follow it down and see how the image is drawn and so forth. So because this one is open, let's look at it a bit. And why not open it with Notepad? We'll open it with a text editor, and just like an XControl, it's just a library. It looks very similar. We have the icons, and we have version information, and then we have our ability VIs. Here we have the ones that we were talking about. Here's the image generating one. Here is the on-click. and it just runs these VIs at certain times. So if we wanted to make this VI, or sorry, if we wanted to make this XNode, let's start with that XNode editor that I referenced earlier. So here is the XNode editor, and again, this is all on Lava, and that will be posted online as you need it. But as you run, we say let's create a new XNode, and it says where do you want to save it. Just going to make a place on the desktop where all my junk ends up. So the first thing it creates is this state control, and this is very similar to an XControl where it has some kind of private data, or like a class where it's got this private data that it interacts with to keep track of its state, to keep track of what it's doing. With our truth table, it's keeping track of things like what are those 4 Boolean values? What are they? What did the user set them to be? Here are all the other abilities that we can create. Now, this list of abilities is actually pulled from LabVIEW resource files. So unlike the XNode manager, which is from, again, the 8.2 era, this actually enumerates them from LabVIEW resources. So hopefully, as new versions of LabVIEW come out, these XNodes that are added just get added here, where the old version, it was kind of hard-coded and you had to update them all the time. So here are all the abilities, and there's a decent amount. Each version of LabVIEW, they tend to add more and update the ones that exist. So the one we were talking about is like on operate click. So once I pick that, it fills in this description, which is again pulled from the LabVIEW resource, and it describes when this ability is ran and how to use it. Documentation isn't perfect, and again, it's incomplete at times, but this gives you a great idea of what the ability does and how to use it, how to interact with it. So I'm going to say create that ability, and it's added to my members over here, and I can double click on it and it opens. So we can look at the block diagram and it's blank, just like, but it's blank, it doesn't do anything yet. But the controls and the description kind of help guide you on to how this should work. So yeah, you can double click there, and on top of that, you can actually open the XNode in the LabVIEW IDE. Now this isn't too useful because without the licensing, you can't look at its members or edit it like an XControl, but you can still do something like a save as. Yeah, you can do a save as, duplicating the entire hierarchy or renaming it. That's pretty convenient to take someone else's existing XNode, save it as your own with a new name, and it will resave all the members in it as well, even though it doesn't show you that there are any members in it because it's locked down. So if you were to make the truth table, you would use something like this. Create the XNode, create the abilities, code in the abilities, which do things like scripting for creating all the code. Speaking of creating the code, before we move on to another XNode, how does this one work? Well, there's the generate code is the output. We see that. We know how it works. But the generate code ability is the one that actually makes the VI. So in here, you're going to see a lot of scripting, a lot of VI server calls. A pretty common practice is to not start with a blank VI, but instead to start with a template. So here we see that we're starting with one of these 2 VIs as our template, either the array or the scalar type, and then we modify it as needed. Usually you'll start with this template, you'll put it in your blank canvas, your block diagram, modify it, and then inline it so that it's in that VI, that you're not calling the sub VI anymore. And that's exactly what this does. We plop it down, we inline it, and then we modify it as needed. What other XNodes are there? Well, I put several of them on Lava, and you're welcome to go check them out. I'm going to demonstrate a couple of my favorites, but what they need to do is, or what they're trying to do is demonstrate different things that XNodes can do that maybe you weren't aware of. The first one with the truth table is clearly you can click on things and it changes how it is, and it's more than 32 by 32 pixels. We've also seen things where you can click and it opens a dialog, or you click and it generates other code. Well, my XNodes have a couple of other neat features. Let's look at the variant repository. And for some reason, I didn't save it in the right path, so it's having a hard time finding it. So here are a handful of examples of what it does, but basically it's a lookup table. It's a CVT, but more efficient. It deals with variant attributes. So in the top half of this VI, we're writing a whole bunch of variant attributes, and then on the bottom half, we're reading those variant attributes back. But one of the things that's different is there's a lot of type adaptation. So I have my initialize, and then write, and here I give it the name, PC name, and I give it the value, PC-103. Username, I'm writing username, and I don't need to give it a tag. That's optional. If it is not wired, it'll read it from the control. So in this case, it knows username has a value of whatever that control is. And then here I'm writing a path. Now you can notice that the path actually has a different icon. It's the color of the path data type. Same with the timestamp and the cluster here. That's because my write or my image creation is actually rewriting based on the data type of what you wired to it. So depending on what you wired, it'll change the icon. Same with you do a read. Here we're reading the string, reading a string. Here we're reading a path, and here we're reading a cluster. Now, on the read, there's a couple of other neat adaptations that we can do. We can right-click and actually tell it select type like a polymorphic VI, and we can tell it the type that we expect it to be. So here I'm saying, pretend it's going to be a path that is a scalar. Now, if I try and read this and it's not, it'll throw a runtime error. But if it is, it just returns. I mean, I know my directory is always going to be a path. But on top of that, I can also have it be automatic. So here, this one I have selecting type, and it's automatic. Now, what does that do? That changes the output of this sub-VI, well, I'm sorry, this XNode, based on what it's wired to. So here I'm wired to a cluster, and it's actually a type def cluster. You don't see any coercion dots because it changes the output to be that cluster type. And I can move this away and wire something else. Let's wire the output to a error. Now we can see the icon changed and the output actually changed. So not only can we change our inputs based on what we're wired to, but you could actually change your outputs based on what you're wired to. It's potentially dangerous, I will admit, but it's some very cool features that you probably didn't think you could do. You know, you can't write a sub-VI today that changes its outputs based on what it's wired to. Even with a polymorphic VI, the automatic only works on inputs, not outputs. If you go through the rest of these examples, they basically demonstrate other features like here we're reading 2 levels. We can read multiple things at once. And this is all configured by this right-click. So I added a right-click, read single tags, and it'll change the output to be a single, or you can right-click and say read multiple tags, and it's now an array. Same with the select type. This is all a runtime menu that I create based on the options, and then automatic is one that I added. So other things XNodes can do is this right-click ability, adapting its inputs, and adapting its outputs. That's what I wanted this variant repository to show off. There's other examples of the variant repository, but you get the idea. It's a lookup table that has some extra flair attached to it. How about the circular buffer? So here's a circular buffer that I made. And the code isn't that complicated, right? Circular buffers are on NI site at various places, and a lot of people have reinvented the wheel, and that's fine. I'm probably one of them. I stole parts of the code from other people's, but here we're initializing, we're creating reuse, sure. I give attributes, well, whatever. So here we're creating the circular buffer. We're telling it how many elements are going to be with this buffer size. We're telling its type is this double, and then in this while loop, we're adding 100 elements at a time, then we're reading the whole buffer. So when I run, I have my buffer size set to 5,000. Oh, and this probably looks pretty strange on a presentation, but you can see at the bottom, the X scale has now locked from 0 to 5,000. And that's because our buffer is only 5,000. We're only going to have 5,000 elements. Now our Y keeps going up, and that's to demonstrate that new data is coming in. But our window is only 5,000. I can change this, and now it's 1,000, and then I can go back to 5,000, and it'll continue growing from the 1,000 that it already had. Relatively simple code, but the benefit of this being XNodes is that it's got type adaptation similar to like a queue. So in this initialize, I'm telling it that it's a double. But I could actually right-click and say you are a U32. And now that init changed to be a U32, and you can see the icons change color, but now the write will only accept a scalar or an array of U32. And the output is always going to be an array of U32. Well, I can take this a step further and have it be things like a cluster of things. So I'm going to have a cluster with a string and a Boolean and how about a double? Now it's going to break other things in my block diagram, and I'll show you why. But the input, again, I'm initializing this. Now when I do a write, I have already the input. So I can right-click and say, like, create a constant. And what is it? It's an array of that cluster data type. Same with when you do a read. I create an indicator, and it's going to be that cluster. Even if I change it to a type def, if it's an enum, if it's whatever, it changes the type of all of the XNodes that are wired using this DVR reference, because it knows the data type that was wired way back here in the init. Just like with a queue, when you do a obtain queue, you tell it the data type, and now when you read and write, when you do an NQ and DQ, the data type is that of what you told it to be. So that's another thing that XNodes could do that you probably didn't think you had the ability to do in LabVIEW. All right, and my last demo of mine is dealing with VI server stuff. Let's say I have on my front panel, I have these 9 buttons, right? This happens sometimes that, you know, developers create a whole bunch of controls and they want to get references to them in like an array and then manipulate all of them at the same time. There's many different ways of doing that. You can right-click and say create references, and now you got all these references, and now I got to put them into an array, and I got to reorder them, and that's all totally doable. But instead, I made this little XNode. First, let's look at the top half, though, because this is trying to do the similar code without an XNode. We have this traverse for G objects, which is finding all controls that have a Boolean class. Then we need to use the 2 more specific class to turn it into a Boolean so that we can then read the label text and then say if it's Boolean or if it contains Boolean, then use it, otherwise close it. And now at the end, we have an array of references that we can manipulate all at once. The XNode down here does this functionally equivalent code. We're telling it find all, find on the front panel all things with a label button, and then we can organize them. The label starts with button or ends with button or is exactly button, but then we can say sort numerically, sort by string, sort by from top to bottom. Well, here is from left to right and top from bottom. And then the output is an array of those Boolean references. So when I run, I can see that this is 1 through 9 in the order that I expect them to be. That's cool and all, but this XNode is much more versatile than that. We can actually right-click it, and here is where we're selecting our VI server class. So in here I told it it was a control, it was a Boolean. Well, let's say I want to find, instead, I want to find, what's a good one? How about a node? I thought, okay.
They said here that maybe you could find an XNode, so.
Oh yeah, I could probably find XNodes. That wouldn't be a bad thing to demonstrate. Oh yeah, because here's XNodes. Oh yeah. How about we find? I wanted to do a loop. Okay, so let's find all 4 loops. So now I said let's find all 4 loops, and I need to tell it that it's actually on the block diagram, not on the front panel. The VI reference I need to tell it is this VI. I think that's all I want to do. So now I'm going to find all 4 loops. Oh, that's probably not going to work. No, it'll work. I should have demonstrated this, or I should have tested this.
Yeah. He's going off script, people. He's going off script.
Oh it's not that bad. Let's do this. So we're going to read the label text on all for loops that are in this VI. So I'm going to add a label so that I can at least see some of these. So now when I run, hopefully it doesn't crap out, we have an array of all for loops. So 3 of them had the label for loop, and 1 of them had the goofy label that I added. So 1, 2, 3, 4. But notice I didn't have to change, I didn't have to use this to more specific class. It knew the class based on what I picked. I right-clicked and said, select VI server class, and here's this. This right-click menu is actually made at edit time. So as I right-click it, this menu is created from all the classes that LabVIEW allows me to see. So this is, again, a feature of an XNode that maybe you weren't aware of. On top of that, I added the other right-click options for like finding all references or only finding one. So I right-click and now it only returns a scalar and it'll return the first one that it matches that. But this
So
is
Brian,
really...
you said, sorry, when you ran it, you said, oh, great, let's see this works. How many times do you have to say, like, cross my fingers and hope that running one of these guys doesn't hose your entire system?
An XNode?
Yeah.
Oh, no. Generally, the XNodes, they're well, okay, I can't say for certain because NI knows more than I do. But generally, XNodes are unstable when you're developing them. When you're creating code that creates code at edit time, that's when the IDE is not happy. You know, if I try and do something like wire a terminal to an input at an output that is the same terminal, LabVIEW might not know how to handle that, and so it'll crash. But once the XNode is written and is in good condition, there's I don't want to say no worry, but there is little worry that there is going to be a problem. Especially when you realize that this VI, this XNode, is just running a VI, and you can right-click and look at the generated code, and this is the VI. I got to clean it up a bit. But,
okay, and there's another question.
Well, just an observation on that. This is in some ways not unlike writing project providers, and you can screw yourself by writing something that in your testing doesn't seem to take a week, but takes a week when you actually use it in real applications if your customer does something he shouldn't do.
Sure.
Not talking about previous experience here.
No, it's never happened.
Well, LabVIEW Scripting is another example where it's like, it's official, it's documented, but you can write code that crashes LabVIEW pretty easily. And XNodes are in that same vein, that they can write LabVIEW code that crashes.
Or any number of, you're definitely playing out in the corners.
Sure.
As a side note, if you do the super secret private special stuff, there's a lot of stuff there that can hose you in ways you do not want to know. I used one once and it killed my code so badly I required a specially compiled version of LabVIEW to fix it. We're talking thousands of VIs.
Wow. Yeah, so I guess the word of caution is if you're going to be playing with this, have a different VM.
Yeah.
Have a different virtual machine, source code control, what else?
Yeah.
Any other words of caution?
Yeah. Bring all your software engineering tools.
Virtual
Yeah.
machine.
You're going to need it.
Okay. So that's all the, I have other XNodes, they're on Lava, and you can go check them out at your leisure, but those are the main ones I wanted to show off. So to summarize, here's a basic list of the neat XNode features that maybe you weren't aware of, or that that I'm trying to demonstrate here. You can detect mouse clicks on the block diagram. You can add right-click menus. One that I didn't demonstrate is you can add and remove terminals, by like right-clicking and saying add terminal, remove terminal. We saw the error ring have that type of feature where I could add %d, %s, and it would add a terminal. But there are other ways of like a right-click add. It can detect things like double clicks to open optional dialogues, and it can invoke writing code as data types are wired. So this is like type adaption, that as you wire anything to me, I change my code. And whether that's just through changing the icon or like the circular buffer, changing the other XNodes that are wired to me. You can create custom icons on the fly as terminals are added or as they're removed. You can redraw it to be whatever size. You can create custom help on the fly. So as terminals are added or removed, you might want to add help in your context help describing those new terminals. And it creates highly reusable code that changes with how you use it. So, you know, if your use cases are relatively contained, you can write pretty awesome code. And even if they're not contained, you can contain them by doing things like break the wire if the user did something that I can't do. You know, so like if I wire with the truth table, it only accepted booleans in a scalar and array form. If I wired a cluster, it would break the wire because the XNode is coded to do that. And then lastly, here's a whole bunch of other resources that I used. I mentioned here the older XNode manager, the newer XNode editor. Other examples of XNodes on Lava, there's a fabulous OpenG rewrite that is a little dated, but it's got some cool stuff where OpenG array functions can accept any data type, not just the polymorphic ones it was written for. And then there's a LabVIEW scripting subforum. There's an older presentation on XNodes. It also goes into external nodes, which you should avoid. That was kind of like XNodes alpha, I guess, if you'd call it, where I guess we are in beta. And then there's also a VI Shots XNode podcast that Michael had that was really fabulous. So that's it for me. I guess. Oh, tell you what. I'm sorry that I jumped around, but I want. No, okay, fine. I already started my sentence. Here is another. Here's my. If I would have said no, I'm not going to show you. You guys would have said, "Oh, what do you got? We need to see it." So I guess I'm just going to show it to you. Here is a XNode, this little function on the side that takes an array of variants and an input that is a cluster, and it will turn those into a cluster. Now, why would you ever want to do that? Well, because this variant to data is really super handy when it comes to clusters. If I give this variant to data a cluster and tell it to turn into an array of variants, then each element of this array is an element of that cluster. So it'll have 4 elements, and the data will be each of those 4 values. So here I said for all elements in my cluster, if it's a Boolean, invert it, and then put it back. And the purpose is not to just demonstrate that you can invert a Boolean, but it's this last part where you can take an array of variants and turn them back. That's generally not something that you can do with this variant to data. If you give it an array of variants and you say turn into a cluster, it breaks. It's not happy with it. But this will actually work. So I can run, and it inverted these Booleans. So I run it again, and it turns a true into a false and a false into a true. But if I change this cluster and say add a numeric, and then add a numeric to the output, it's happy now. It took that new cluster and turned it into the new cluster, and it only accepts cluster types. So if I wire something else to it, it says, hey, that's not a cluster. I'm not going to run. The code is so simple. I was happy with this XNode because it took like 10 minutes to write. All it is you take the array of variants, you turn it into the array to cluster, turn that into a variant, and now you can get that data back out. But the trick is this little array to cluster needs to be set to the right size. So cluster size here is 5. Well, if you put this code on your block diagram and the cluster is the wrong size, it won't work right. So this will actually change that value. It will right-click cluster size and set it based on what's wired to it. So that's the trick. That makes this work. Very simple code that just says change my output based on my input. Again, something that we've seen XNodes have the ability to do. So I think that's it for my demos. All of this is going to be posted online if it hasn't already. And yeah, I guess is there any other questions? Did I go too fast? Sometimes I get all excited and
Nobody fell asleep.
Nobody fell asleep? Okay, that's good. Presenting remotely, it's hard to know. It's hard to gauge the audience.
Yeah, there's just Nava's miles around, and there's a question.
So, I'm a little confused on the purpose of the license. I mean, what can we do? We don't have a license. No, right? Can we just look at XNodes? Can we create them ourselves? What can and can't we do without the license?
So, with the license, you could edit XNodes within LabVIEW. Without the license, you can edit XNodes using this XNode editor. And again, all it's doing is making plain text. All this, if you look at the code, you know, I mean, it calls a couple of methods on those libraries, but all it's really doing is creating these XNodes with text. So like here is that array of variants cluster, and down at the bottom, here's all the abilities that it added. So to basically, with a license, you can do it in LabVIEW. Without a license, you can do it with this.
And that is found in Lava, right?
Yep.
You said?
Yep.
And when he says do it in LabVIEW, what he means is you can have the XNode up like in project or a library viewer.
Like you would do with an XControl?
Click on the XNode and do like add new ability or stuff like that, and you can't do that without the license.
So to repeat, what Darren said is what you mean by not having it in LabVIEW is that you don't have a project provider. It's like it's not on the project that you have your library of XNode. You have to go to the file explorer.
Right. I mean, like if I did a file new, I can pick new XControl, and it'll make a new XControl. With the license, there would be a new XNode so that it could make it here.
All right, so from the remote audience, Chris Ralph says, good presentation, Brian, thank you. And viewer 11 sent a link to an he said this is an XNode 2, and it's basically, let me see what it is, let me click on that. It's an NI VeriSend add-on, an FPGA XML builder node. So that's also an XNode.
Oh, that's neat.
Yeah.
All the FPGA code is XNode.
Right.
Yeah, so
They're all XNode. That's what XNodes were really invented for.
Mr. Dr. Gray here is saying that all the XNodes, everything on FPGA is basically XNode.
All the purple nodes.
All the purple?
Yeah.
But there's
Yep.
no ability.
You'll see the XNode wizard, and there'll basically be nothing populated there. A lot of it changed the internal structure. I don't think it's the LabVIEW XNodes anymore.
Okay.
So.
Do you hear that,
Yes.
Brian?
Yes.
What does it look like to make structure like a loop? Right? Talking about time loops for next. What does it loop like to create some sort of container things you put inside of it?
The time loop itself is not the gears hanging off the side. The loop itself is still a loop. There's no way to make a structure. Okay. An important point here is that XNode versus the block diagram and XControl.
Okay, so he's going to the loop there and right-clicking on the XNode stuff.
If you want to
Yeah.
make a custom use an XControl, you want to make a custom block diagram, object.
Yeah, I just wanted to demonstrate that a time loop is an XNode.
Parts of it are.
Parts of it. The loop, still a loop, is the things that are hanging outside that are the XNodes.
Yeah. Hey, one other thing I just remembered. Another interesting thing is like on the add-ons, there's this find add-ons, and if you click it, it opens Internet Explorer to this tools network, which is really super handy, right? I can put something on the block diagram that brings me somewhere. How did I do that? Well, I actually made that on my own library where I have show application builder tools, and now it opens a folder where I have a whole bunch of tools that I can bring people to. That's also an XNode that is just on first creation, do something. And in this case, it is open a folder or go to a web page. So sorry, I forgot about that. That's another type of XNode function that I didn't go over.
There were several calls back here. There were several, oh, that's cool.
Yeah, because you didn't know you could do that. I didn't know you could do that.
There's another question in the back.
Yeah, do we see like decreases in performance for running XNodes? Is it similar to running a sub-VI or like an inline VI? Yes.
Yeah, I was going to say NI will probably answer it better than I, but as far as I can tell, it's an inline VI.
You have to be very careful. Do performance.
Well, hence,
Oh yeah, like I can mess up myself.
yeah, hence that comment about you can put something in there
Oh, yeah.
that takes a week to run.
So basically, the quality of the scripting that you use to create it is going to...
And even then, the scripting is only edit time stuff.
Oh, yeah.
When it's running, it's effective.
Okay.
So Darren said that it's effectively a sub-VI code.
Once it's generated, it's static.
Yeah.
Edit time, I'm trying to picture all a bunch of stuff could really affect your.
So does it get bundled in, does it get bundled into the DI file then?
Just imagine whatever scripted code is made by the XNodes.
Yeah.
Imagine that sitting on the diagram for the XNodes being called. Imagine.
Okay.
That's how LabVIEW SVI went out.
So you now have another little block of code sitting there that is invisible at edit time, but gets popped out.
Yeah.
Okay.
It's basically like this, right? This is the generated code, and this is how it would basically execute. It's there.
Okay. The compiler just swaps it out.
And that's an interesting point is when it comes to EXEs is, there's no real, and again, I only can speculate, but I assume that when an EXE is made, a lot of these things like the VI that handles the right click, that those wouldn't be included in the library because those aren't used in a runtime engine. There's no block diagram to right click on. Darren, can you say if that's true or not?
So that implies that you would have edit time for both hits, but not.
Right, because it's only edit time. Once it's generated, that's what gets included in the XC. That was
So you had a bunch of links there, and I know you're going to be attaching the presentation, but I'm also getting questions from remote attendees that where can they get it? Like, is there a single place where they can get all this stuff? So I think we're going to add your demo code or links to where that resides, and then make the document for this meeting have links to that.
Okay.
Right?
Yeah. Everything will be available for sure. There's no reason I can't give you everything I demoed.
Okay, Terry, are you okay with that? Is that enough good answer for you? Hopefully, he says yes. Anything else? Anybody else? Any more questions? No, we're good. Well, thank you so much, Ryan. This was awesome. I told Alan this is such an in-depth topic that it's either going to be wow or I'm going to be crying at the end. I'm definitely on the wow side. So,
thank you.
Any other comments? No? Then good. All right, this gets uploaded as soon as I say stop recording, and then I forgot to thank SixClear, but I think it's obvious that they are hosting the remote since you went to join.me/SixClear. And then Jasim is going to help us do the editing, so you remove all the noise and stuff, and it will be up on our YouTube channels on Laugh Tracks, and also on the details for this meeting, we embed the videos back after their process. So thank you again for joining. You're free to stay. Normally we go until 8. I think it's the first time that we have actually time to mingle and discuss things. So if you want to stay around, you're welcome to.